Today we're going to talk about systems of equations. So system of equations is two or more equations. Solution to a system of equations is the ordered pair, so the x and y value, where the equations meet. So, if we were talking about linear systems are two or more lines together. And so, we're just going to talk about two lines right now. So, no solution would be two lines that never meet, because if a solution is where they meet and there's no solution, they wouldn't meet. So, it'd be two parallel lines. Nonlinear systems means different kind of shapes. So, we're going to use like two U's as an example. So, two U's that would never meet would look like that if they were right up and one was upside down. Or you could have a big U and then a skinnier U inside of it. That would also have no solution. One solution, they would meet once. So all you have to do is make two lines that meet just one spot. Nonlinear systems, if I'm talking about two quadratics, the way that you can make them meet only once is if you had them just touching right there at the top. That is one solution. You can also have a quadratic and a line. So you would have your quadratic and the line would just skim along the side of it. It's called tangent, if you remember that from geometry. Infinite solutions. These ones are sometimes kind of hard to see, but if something infinitely touches, that means that they'd be right on top of each other. So like that. There's my second line, right on top of each other. And the same thing as quadratic, and the second quadratic would just be right on top of it. Two solutions. If you have three lines, you could make two solutions. If you only had two lines, though, you could not have two solutions because one of the lines would have to curve, and then it's no longer a line. When it comes to nonlinear systems, to get two solutions, I could have my line just passing right through it like that. You could also have, if you had two U's, it would be like that, and they would cross through each other twice. So now you know the different kinds of solutions. What are the solutions? So when we're looking at these graphs here, if I ask what are the solutions, all you would do is pinpoint where they're crossing each other. So it's no longer where they're crossing the x-axis, which is what we've been doing for the past couple days, but it's where they cross each other. If I would eliminate that line, then I would be asking where does it touch the x-axis. So I write out those ordered pairs. That's 5, 3, and 0, -2. So that had two solutions. This one only has one solution, and I would say the ordered pair for that is 0.5 and 2. So there are three ways to solve systems, and so I'm going to show you all three ways. I do not care which way you choose to solve it. I am probably going to guess most of you are going to do the graphing method. So how you do the graphing method is you do very similar to how we have been doing it. So you go and grab your calculator, and you put both of those equations into y1 and y2. So I do -2x plus 9 into y1, and I do 3x minus 4. You do not need 0 in this. So then I do the second trace, 5, just like I normally do it. And you should notice at this point that this only has one solution, so I just have to hit enter, enter, enter. And that's my answer. You have to write the x value and the y value, so 2.6 and 3.8. So it's pretty easy. Now, by substitution, if this is the way you choose to do so, what you're doing is you're substituting one function into another. So they both equal y. So if they both equal y, that means they equal each other. So I am just going to set them equal to each other. And I'm just going to solve for x. So I'm going to add over 2x. Get 5x, and I'm going to add over the 4 and get 13. Divide by 5, and if you do that, you would get 2.6, which is exactly what we got when we did the graphing method. Now to get the y value, what you do is you take that 2.6 and you plug it into that x or that x. Either one, you will get 3.8 if you plug it in. For elimination, what you do is you line up the equations right underneath each other, so that the y's lined up, and the x's are lined up. And then we're going to turn it into a big adding or subtracting problem. So the way you determine is it adding or subtracting is which one will eliminate a variable. If I add down, nothing will be eliminated, but if I subtract, y minus y is no more y's, 0. So we eliminated a variable. Now I do negative 2x minus 3x is negative 5x. And I do 9 minus negative 4, which is 13. And now I solve this for x. So subtract 13. I get negative 13 equals negative 5x. I divide by negative 5. And sure enough, x equals 2.6 again. To find the y value, I do like I did in the last problem, and I plug it into either equation, and I get 3.8. Let's do another one. Now we're talking about some quadratics. So solving by graphing. Before I solve by graphing, this second equation is not solved for y, so I'm going to subtract over x squared first. So it'll be y equals 8 minus x squared. So now I'm going to take my calculator, and I'm going to plug it in. And I'm going to look at the graph first. So this one has two solutions, so I should have two ordered pairs. So second trace 5, enter, enter, enter. And I get 2, 4. I got to find my other one. So second trace 5. I have to move my cursor or else it will just keep finding the same one. So as long as it's closer, then I hit enter, 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 and I get negative 2, 4. So my two answers are 2, 4 and negative 2, 4. All right, if you're going to do substituting, you're going to substitute one function into another. And so you could, I'm going to take that first one. The first one says y equals x squared. So I am going to take that y equals x squared, and I'm going to plug that in for the y down there. So it's going to look like this, x squared and plus x squared equals 8. Okay, so where the yellow is where the y originally was in that second equation. Now I'm going to just simplify it up. So x squared plus x squared is 2x squared equaling 8. I divide by 2. I get x squared equaling 4. Now there are two numbers that you can square and get 4. The two numbers are 2 squared equals 4 and negative 2 squared equals 4. So that gives me an indication that this answer has two ordered pairs. So one with the x value being 2 and the other x value being negative 2. Now to find the y values, I would just take both of those x values and plug it into either equation, and I would get 4 for both of the y values. For elimination, I'm going to line it up, so y equals x squared, and I'm going to use the y equals version that I have on the second one, y equals. I'm going to move that negative x squared out front, and I'm going to move the 8 out back, so I just flipped-flopped those positions. Now, if I add down, I will be eliminating the x's, and if I subtract down, I will be eliminating the y's. So you just decide what you would like to do. So I will just add down. So when I add down, I get 2y. The x's cancel, and I bring down the 8. Okay, so then my y value is 4. And then when I plug 4 into one of the equations for a y, I have 4 equaling x squared. I plugged it into that first equation. And that takes us back to the same spot before. Two things make x squared equal 4, and that's 2 and negative 2. So those are my two answers.